Okay, something smoked. That's not good. After 8 months of waiting, I actually building the PCBs for our competition rocket. The PCBs finally came. Really excited. We ordered JL PCB, got assembly just for certain things, and I'm excited to check them out. Let's see. Gonna do an unboxing. Got 2 of the boards, the flight computer and the camera control board. We're still waiting on 2 more, which are gonna be our control boards and our can sniffer board. So that's what it looks like inside. Let's see. Here we have the PCBs. Wow, it's way smaller than I thought. Whoa. So there's our PCB. Wow, it looks so sick. Okay, now let's see the assembly, how that looks. Wow, awesome. Okay, so this is the assembled board. Has all the chip, no connectors because we would just solder the connectors ourselves, but the logo came out pretty good. I don't know if you can see it. I'll try to zoom in, focus it, there. But got our pyro channels, got our LoRa right here, USB-C, SD card reader, our buzzer, our STM32 microcontroller, our UTS logos. It all looks pretty good. Looks really good. Back. I'm excited. Now I need to plug it in and see if it works, but everything is looking A-okay at this point. This SMA connector might be the wrong one that we actually use, so I might have to switch that out, but I think it should be fine. But yeah, sweet. So that's the flight computer. So this board, the next board, is the one that controls the cameras. All the characters came out readable. I made sure to make sure that they're the right size. Got the ST-Link thing. So the first thing that happened when the boards arrived, the LDO voltage regulator footprint was reversed in KiCad across all my boards. I ended up frying one of my LDOs the first time I plugged it in, and the magic smoke that was in it came out. The fix was to bodge the wires, as you can see here. That's not how it's supposed to look. Sometimes you have to do something sketchy like this, but at least it works. It's been about probably 8 months since I started on the rocket, maybe 9 months actually, since I started on the rocketry team. I didn't know anything about PCBs or anything, and I designed all the ones that are going into the avionics, so that's really fun. We're finally, like, this is the first time I'm seeing the rocket together, and it's really exciting. We're hoping to launch at the end of the month. We don't know yet for sure because we were actually supposed to launch last weekend, which is a good thing because it gave us more time to refine everything. Hopefully by the end of the month. We still need to do a pop test. We still need to figure out the avionics mounting. The avionics, for the most part, besides the air brakes, are completed. We are probably going to launch without the air brakes first to get reliable data, and then the avionics mount needs to be completed. Tell us about your avionics bay.
It's basically, we're trying to assemble it. We're trying to get heated inserts in so that we can mount the PCBs and everything. And then we also got to glue down the mounting plates to the fiberglass rods, put the metal base on. Hopefully things go well. Fingers crossed.
Are you going to be soldering everything?
Bro, you already know, bro. I'm master of soldering. That's what I do.
So we need the integration. So basically the avionics will sit up in this nose area above the payload, and we just have to worry about sizing, but I think we'll be able to work around this. We actually have a lot of room. Yeah. So this is the payload, and this area is ballast, so we can put plates in here, which will increase stability. And then this is the DMS project, so it's actually, there's different materials in here, and the electronics measure the vibrations of the different materials while under high G-forces, so that's the scientific payload we have on the rocket. And then the air brakes, word explain that. And then in here will be our parafoil recoveries. So we'll actually have a parafoil in the body tube. There'll be 2 servos and spools to hopefully control a descent. That's probably our most ambitious project for the rocket, but they didn't allow us to do roll control, so that's what we're working on now. And so like it just goes in like this. We still have to work on integration because this was just made. There's a lot of sanding and cleaning up to be done, but generally this is what the rocket is looking like. Okay, so I don't want to mess with it. So we'll move it back. So that's basically what the rocket's gonna look like. So this is the coupler, so this actually fits inside the aft body tube. It's actually gonna be a massive rocket. It looks really good though. So we have carbon fiber in, we actually have a boat tail because I don't know the mechanical advantages of it, but it does help us in some way. We can get a mechanical person to explain that, but it looks cool. And then we're actually doing a motor eject that pulls the drogue. So the drogue will be in here, and we'll have a charge that's controlled by the flight computer, and it'll eject the motor case, the done motor case, and it will fire the drogue through the rear, and it'll pull out. So this is our ground station. This is currently a work in progress, but the flight computer transmits over LoRa, and it's basically just a Raspberry Pi with a LoRa module wired up to it, and it acts as a receiver and a transmitter. So basically, if you look here, we can arm the rocket. So when we arm the rocket, it will send a arming packet to the flight computer, and it will change from state idle, which is the disarmed state, to armed, which means it's ready to detect a launch and can fire and can go through the flight states. We've run a couple audits. There's still some edge cases that we have to think about, but we're getting close to a comfortable, portable flight computer.